on the East Coast, and I'll get things started. Good afternoon, everybody, or good morning, depending if you are on a different time zone. And thank you for joining us today. As you've heard on the audio, this meeting will be recorded. My name is Patrizio Cernetti, and I'm a senior fellow at the Wharton Customer Analytics, which is a program connecting industry and research and students with the goal of innovating the field of data analytics. In my past roles in supply chain and in my current engagement in energy management for commercial buildings, I have developed and made good use of artificial intelligence and machine learning to improve processes and enable new capabilities. So personally, I have a vested interest and I'm very fascinated about the potential of AI as it's applied on our everyday life. And also I write daily about it. But also I'm also conscious of the challenges that a rapid growth of the new technology, any new technology, and AI in particular, brings with it. That whether we like it or not, and whether we realize it or not, many forms of AI are already around us, and we interact with them every day. So to help us develop our critical thinking about and around AI, I have the pleasure of having Kartik Hosanagar with us today. Kartik is a professor of technology and digital business at Wharton. He's also the director of Wharton AI for Business. He's also an entrepreneur, launched a number of successful startups, and most recently, he's working on JumpCut, a startup that is using data to teach data and tech to democratize Hollywood. We'll probably hear a little bit later. Kartik will take us through some examples of applied artificial intelligence and also discuss how companies, individuals, and society at large can position themselves to make good use of this technology. This session will be followed by Q&A, so please feel free to add and interact with us over the chat and send us your questions, and we'll have a healthy Q&A session at the end. So without further ado, Kartik, if you want to take us through your presentation. Thank you.
Thanks, Patrizio, and thanks to the Alumni Club for inviting me. It's a great pleasure to be here. And by here, I mean my own bedroom right now. It's a very unusual format, but nonetheless, I'm glad we could do it. Yeah, so I will share my screen and hopefully you all can see this. A brief presentation, and then we'll have time for a conversation and Q&A at the end. And just want to do an audio check. Everyone can hear me because I see one individual is not, but then okay, Patrizio is saying the audio is coming through. Okay. All right. So as Patrizio mentioned, I'm a professor of technology and digital business at Wharton. I am also the faculty director of our new AI for Business initiative. And the reason we set this up is just recognizing how AI is likely to have a very transformative impact on business and society, and trying to lead some of the thought leadership and the reskilling needed for consumers and businesses for the same. My research over the last I joined Wharton in 2003, so yeah, 18 years or so has been broadly on algorithmic decision-making, data-driven decision-making, but specifically as it relates to the tech industry, so e-business and related areas like digital media, digital marketing, and so on. I was previously a co-founder of a company called Yodel, started it with a couple of my undergraduate students, and we grew it and sold it in 2016. And I'm currently running a startup as well. And also I'm an author of the book, A Human's Guide to Machine Intelligence, which was published a couple years back. I'm contractually obligated to keep reminding you of this book every 2 minutes, which I'll avoid doing, but don't be alarmed if it happens. All right, so when I was writing my book, I interviewed many people all over the world in exploring how people are used, sort of looking at people's daily lives and the role of technology in the daily lives and so on. And one of the more interesting people I met was a then 22-year-old Yuan Jun in Shenzhen, China. Now, what was interesting about Yuan's daily life was how she had a almost daily conversation on WeChat, Chinese social media app, with a social media celebrity by the name of Xiaobing. Now, Xiaobing was a teenage girl, 13-year-old girl, who had 40 million followers on social media. And what was amazing was that Xiaobing was having a daily conversation with some of her followers. And in fact, I later discovered that Xiaobing has such a strong fan following among these followers that nearly a quarter of these 40 million followers have said, "I love you" to Xiaobing at some point. And so what was interesting was, how is it possible that somebody with 40 million followers is able to engage in these kinds of conversations on a daily basis with some of her followers? And of course, if you peel the layers a little bit, you find out that Xiaobing, also known as Xiao Ice, is actually not a human. Xiaobing is actually a chatbot that was created by Microsoft. And it was a chatbot created in the persona of a teenage girl, and was capable of engaging in fun, playful conversations with all these followers. Now, driven and motivated by the success of Xiaobing in China, Microsoft decided to build a similar chatbot in the US, again in the persona of a teenage girl, and released on Twitter in 2016. Now, interestingly, soon after, in fact, within an hour of Microsoft releasing this teenage chatbot on Twitter, this chatbot ended up engaging in racist, sexist, fascist type of conversations on Twitter. And within a few hours of being launched, Microsoft shut down that chatbot, which many of you would have likely heard of, which was called Microsoft Tay. And in fact, later that year, MIT's technology review listed Microsoft Tay as the worst tech of the year. And they have an award they give out annually, which is the worst tech of the year. And that year it went to Tay. Now, Microsoft's experience with Tay raised a question for me, which is, how is it possible that two similar chatbots created by the exact same company had such different outcomes, inspiring love and affection on the one hand with Xiaobing, and becoming this racist, sexist chatbot with Tay? And what does that mean in general for how AI is being rolled out in various parts of our life, right? So that's something I want to talk about, but I'll really come back to that theme a little later in this talk. But I'll begin first by talking a little bit about, what is AI, what is machine learning? We hear this term all the time, but just demystify it a little bit for those of you who aren't deeply immersed in it. I'll then talk a little bit about what it means for business, why managers should care about it, and how to leverage it for success within an organization. And finally, I'll come back to these kinds of issues on what can go wrong and so on. So first, in terms of what is AI, quite simply, AI is about getting computers to do the kinds of things that require human intelligence. For example, being able to understand language, being able to recognize objects, being able to learn, and so on. And there are many ways in which one can build artificial intelligence. In fact, the most popular approach in the 80s and 90s was an approach known as expert systems. And in fact, these systems usually involved interviewing people who do the task that you're interested in automating. You interview people and ask them how they do it, and you codify the rules they use and essentially convert those rules into a knowledge base, right? So for example, if I wanted to create a medical diagnostic system that can diagnose diseases, I would interview a few dozen doctors and ask them, how do you diagnose diseases? And they might give me a set of rules. For example, they might tell me that the way to diagnose diseases is for example, if somebody walks in to my office, if they have a cold and no fever, then I go down this path. But if they also have a fever, then I ask how long is the fever. If it's under a week, then I explore viral causes. If it's over a week or over 10 days, I explore bacterial causes. And so they might have a set of rules they might articulate. And of course, I'm not a doctor, so please don't ever use the rules that I just mentioned. But the point being, you ask a doctor, you understand the rules they're using, and you codify them, and you convert it into this knowledge base. Now a new patient comes in, you have their symptoms, you look at the rules, and then based on the rules, you have a diagnosis. So that's how expert systems work. Now, an expert system like the one I just described will work super well for something like tax filing, because you can really codify tax into a nice set of rules. Harder with something like diagnosing diseases or driving a car. And in fact, efforts to use expert systems, for example, with medical diagnosis, often came up short, meaning they worked reasonably well, but couldn't really match up to human doctors. And similarly, you build a driverless car that's based on asking people, hey, how do you drive? And you write down the rules. I asked Patrizio, how do you drive? And he gives me a bunch of rules. Oh, if I'm too close to the car in front of me, I apply the brake. If the car is too slow, I switch to the left lane. And so he might give me a bunch of rules. And I could spend hours with Patrizio and in fact, with all of you, write down every rule you give me over days, in fact. And if I unleash that car on the road, none of us want to be near that car, right? Because the reason is there is so much we know that we are not able to tell, that we are using, our brains are using, but we don't even know those rules. This is, in fact, an idea that MIT's economist, author, talks about as tacit knowledge. We all have tacit knowledge, meaning we all know more than we can tell. A simple example of it would be that if I asked you to give me the rules to recognize your mother's face in a set of images, and I see my mom is one of the participants, so I brought up that example, and I want to identify how to recognize, or you want to recognize your mother's face in a set of images. We can sit down and you can give me all kinds of rules, shape of the face, color of the eyes, and all kinds of features. But if I apply that to a few thousand photos, that AI system will probably not be able to recognize the face, because we all know more than we can tell. And so that's why expert systems really fail when you're applying them to complex tasks. And this is where the modern revolution in machine learning comes in. Machine learning is a different approach to build artificial intelligence. And that a different approach to build AI would be that instead of asking people, how do they make decisions, we observe them in action and we record that data and allow a system to statistically look at patterns in the data. So instead of asking doctors to give us the rules, we will instead collect data on what were the symptoms patients walked into hospitals with and what was the final diagnosis by the doctor. And if we have this data for millions of patients over a few years of visits, then you've got a massive data set from which a system can start to look for patterns. If you've got cameras that you can attach to cars in the front, in the back, on the sides, and you do that with a few thousand cars and record what the drivers are doing over a year, and then you have a massive database that says, here's what the person saw in the front, on the sides, and at the back, and you have data on when they press the gas, when they press the brake, when they switch lanes, and all that stuff, which again can be used. And that's the idea behind machine learning, which is the tacit knowledge is actually in data. And we can look at the data and be able to infer that. And we can do that only if you have massive, very large amounts of data. This was not feasible 20 years back. And it's only feasible today because one, digitization has just resulted in all kinds of data being recorded. Improvements in computing means storage cost is really low, and processing cost to process that kind of massive amount of data is also low. So it's an idea that's been around for really long, but it's an idea that works today because of these things that I just mentioned. And there are many examples of this. You want to classify emails as spam. Then you again take a massive data set of emails coming into people's inboxes and ask which emails did people explicitly label as spam and which ones did they not. And that becomes the training data set. If you wanted to recognize images, say, recognize people's photos, then you take a massive database of millions of images. And then you have, if people have labeled those images and said, this is so, and this is person A, this is person B, then you start to build a system that can now recognize people's faces as well, and so on. And a driverless car, again, would do similar things. Take lots of images and you label, here's the road, here's a tree, here's a person, and now the system gets really good at recognizing the patterns in the data. So that's machine learning. Now, why does all this matter? Why does AI and why does machine learning matter today? It's because we are starting to see AI and machine learning as what one might call as a general purpose technology. Now, a general purpose technology is a technology that we see as something that has widespread use of that technology across many industries. It's a technology where usually there's a high volume of research activities. And so usually that implies that the technology is improving very rapidly because of ongoing research. And also we observe that the research activities are also spread across many industries. And if so, then again, the impact across many industries is quite significant. In the past, we've seen many examples. Electricity was a general purpose technology when it came out. The internet was a general purpose technology when it came out. And the question, of course, is, what are the new general purpose technologies? Now, if a technology is a general purpose technology, then we know that it has a huge impact on organizations and economies. At the economic or the macro level, we know general purpose technologies stimulate innovation and economic growth. And so it's important for countries to invest in those general purpose technologies. And also at the organizational level, we know that general purpose technologies have a huge impact on product strategy and company strategy. And as we have seen, for example, with internet and digitization. And generally, if a technology is a general purpose technology, we would typically recognize that most industries will be affected by a general purpose technology. And because there's a lot of research activity, that technology improves slowly, steadily, until one day it suddenly reaches a point where it can be really have a mainstream large-scale impact, and therefore the impact of these technologies may often come with a lag, and we might not see it right away. Now, the question is if machine learning is a general purpose technology or not. And a lot of the evidence suggests that it is. So for example, a recent research paper by researchers Avi Goldfarb and his colleagues in Canada looked at jobs in machine learning and related AI professions. And first of all, they find that of all the machine learning jobs, a pretty significant portion, nearly 15% of the jobs, are research-related jobs. So that's one sign that there's a lot of research going on here. Also, you can look at where are the AI and machine learning jobs and how are they distributed across industries. And you see a pretty healthy distributions of machine learning jobs across a number of industries like finance and education and healthcare and manufacturing and consulting and professional services, retail, and so on. In contrast, many other technologies, like if I were to pick nanotech over here, it's mostly education and in professional and scientific services. And you don't see that wide distribution. In contrast, you see something like cloud computing, again, widely distributed across a number of different industries. And AI, and in particular machine learning, tends to show that capability as well. Also, if you look at the research jobs, those research jobs are also distributed across many different industries as well. All of these suggest that, first of all, AI and machine learning, there's a lot of research, it's improving quite rapidly. The jobs are seen in many different industries. The research jobs are also seen in many different industries. All signs that it looks a lot like a general purpose technology today. And if it is a general purpose technology, there are implications for many industries and many companies. So, by the way, I'm not able to see all of you and I'm not able to see the chat right now, but what I'll do is I'll take a break at the end for Q&A and chat and so on. Coming back, we're seeing evidence that AI has properties of a general purpose technology. An implication of it is that it will have an impact across a large number of industries. We're starting to see that, and I'll just pick a few industries just as an example. Finance, for example. AI is starting to show some pretty important applications in financial services. One good one that I've spent some time looking at is machine learning in fraud detection. And that could be many different kinds of fraud, credit card fraud, or other kinds of financial transaction fraud as well. And again, here, if you have a massive data set of billions of different transactions, and these are nicely labeled where you know which few of these were fraudulent and which ones are not. And you have the attributes of these transactions. What was the amount that was billed? Which country was it billed? Where is the person resident? What are their typical transaction history and profiles and so on? Then you can train a machine learning system to recognize patterns of fraudulent transaction. And in fact, these systems are already being used today. I mean, for all of us, machine learning has changed how fraud is managed. As recently as 10, 12 years back, we would have to review the credit card transactions and then call the company and say, here's fraud. Today, when we are transacting, we'll get a text message to confirm that a particular transaction is legitimate or not. And that's an AI system that's kind of checking whether this transaction looks suspicious or not. And if not, messaging us and getting that validation before proceeding. And beyond fraud detection, you have identity verification. For example, a lot of banks in China are installing face detection to recognize people at the ATM, so you don't even have to enter your PIN code. And based on the face, it logs you in loan and insurance underwriting, in predicting loan outcomes and so on. So many different applications. Of course, financial services is also heavily regulated. And so a lot of AI is in research in financial services. Not all of it is out yet because of some of these regulations. Moving on to transportation. Of course, this is a sector where AI will likely have a huge impact over time. Driverless cars being the main drivers of this kind of impact. Again, if you look at these driverless cars today, they are very expensive because there's very expensive and clunky hardware to be installed. The software is not perfectly reliable, as you can see with some of the Tesla accidents, rare, but nonetheless rookie mistakes in those accidents that have happened. Yet the rate at which things are improving, it's pretty clear that we should expect autonomous vehicles supported by AI as being a primary mode of transportation in the coming decades. And finally, we also have applications, sorry about that, applications in, say, media personalization. Classic example is algorithmic recommendations we might see on say Amazon, people who bought this also bought that, or on Netflix, where again, media is recommended to us, or Spotify, or even in very critical decisions like who we date and who we marry. So Tinder or Match.com, almost all the matches are made by algorithmic recommendations. And these systems are known to have a huge impact on choices people make. So for example, at Netflix, research shows that 80% of the viewing hours streamed on Netflix are driven by algorithmic recommendations. And similarly on YouTube, 70% of the time people spend on YouTube is driven by algorithmic recommendations. So again, the point is that AI is finding applications in many industries. And it's not surprising that, for example, a recent report by MIT and BCG suggests that 90% of companies they surveyed had made investments in AI. And out of this group, about 40% had already started to see some returns. While some are starting to see returns, the vast majority actually said they were not seeing returns. And even the ones that saw returns are also seeing many examples of AI failures. And there have been many instances of big moonshot AI initiatives that some companies have invested in that have failed. For example, chatbot use to handle customer service requests and so on haven't really lived up to all the hype and investment that has gone into it over the last 10 years or so. And so this begs the question of what does it take to actually get business returns from AI? So if you want to roll out AI in your organization, what does it take to succeed with AI? And I've spent a good bit of time on this question, interacting with a large number of companies and consulting projects. In fact, one of the early such initiatives was Google trying to reinvent itself as an AI-first company many years ago. And I worked closely with an exec at Google on their AI-driven business transformation. And he and I have written a fair bit about some of our experiences with rolling out AI in certain pockets within Google. But even outside of Google, looking at companies that have nothing to do with software technology, for example, in pharma and others, you're starting to see AI play an important role. And so the question is, what does it take to succeed with AI? And I want to mention 5 key themes here. The first one is this point of view AI as a tool and not an end goal by itself. And this is something that's somewhat intuitive and straightforward, and yet almost 90% of the companies I talk to make this mistake, where AI almost seems like the end goal. It starts with what can we do with AI? What should be our AI initiative? How do we roll out AI? And instead, the question to be asked is, AI is a tool. So the question is, what's our strategy and which of our strategic initiatives or priorities can AI actually support? Which is a very different question. And it requires working backwards from strategy rather than working forward from AI. I think what's important to recognize here is that the real power of machine learning is to take high quality training data and be able to learn from that and make predictions with that. And the question is, what can you do with better predictions? And that's the question every company should ask. For our strategic priorities, where is it where better predictions can help? And where is it that we have data to help aid those better predictions? Classic example is fraud detection. Banks routinely lose billions of dollars to credit card fraud on an annual basis. That's a huge amount lost to various kinds of fraud. And better prediction and prevention is just going to be a huge impact to the bottom line. And so that's a classic example. The second strategy is to take a portfolio approach to AI. And many companies that I've worked with usually had a big moonshot AI initiative, and they bet the farm on that AI initiative. And in fact, the entire success of the data science team depended on whether that big moonshot initiative succeeded or not. And usually the outcome after 4 to 5 years is that it did not. And that's because, again, that was a fundamentally flawed approach. The approach that I've seen work involves investing in a portfolio of AI initiatives And that portfolio includes several projects that are focused on quick wins and a few projects that are focused on long-term initiatives. And for quick wins, we're talking about something that's optimizing a simple touch point. Usually, maybe it's an employee touch point. It's not something that's likely to produce any ROI immediately for the business. In fact, the goal of these quick wins is really to help the organization gain experience with modern machine learning, which involves data collection, data quality assessment, data labeling, and then looking at the AI predictions and figuring out, how do you work with those predictions? What do you question? Where can it fail? What kinds of questions to ask from a managerial standpoint of your data scientists and so on. So it's really about helping the organization gain experience and gain internal consensus about the potential here. And it's not about ROI. A simple example would be take an off-the-shelf machine learning system and figure out how to use it in very simple internal employee touch points. At a pharmacy, that might be a voice interface for our pharmacist to be able to figure out which drugs are in stock instead of typing it in a computer and logging into a specific application. Probably has zero ROI, but it's about getting people comfortable with these kinds of things and getting your engineers and data scientists comfortable with building AI systems with user interfaces and looking at what goes wrong when there are actual humans using these systems and understanding how to fix those problems. Another example, at Amazon, every meeting starts with people walking into a meeting room back when, meetings were in person and just saying, Alexa, start the meeting. And Alexa would then, dial in, all remote participants would be let in. It would enter the PIN code, the passcode for the meeting and all that stuff and get everything activated. Very simple, straightforward. The idea is for everyone to get used to using AI, seeing the benefits of it as consumers, and also for your engineers and data scientists, seeing what it's like to roll out AI with actual users. And then you have a few long-term projects. And these are about redefining and rethinking end-to-end processes, in fact, usually involving customer interaction. Here we've got to find processes and things or activities that support existing strategy. It's important to not just think about AI as a cost-cutting tool, but also as a growth driver. What can we do to change how we interact with consumers, for example? An insurance company could say, hey, we want to reimagine how we process insurance claims. And our goal is to get to a point where 80% of claims processing happens completely automated, and only the most complicated cases go to humans who can then take the time to get those cases right, rather than be overwhelmed with all the cases coming in. And in fact, Lemonade, which is a new insurance tech company, is really built around reimagining insurance with data as a foundational pillar for an insurance provider. And they're doing that, and a lot of their claim processing is all automated these days. Again, Google, when they first rolled out AI, it wasn't just a moonshot initiative like driverless cars that they announced. It was actually a portfolio approach where their CEO, Sundar Pichai, required every product team to figure out how to roll out ML within the product. And they were specifically told, it doesn't matter whether there is any ROI from your ML rollout, but I want you to roll out something in 6 months. And when he says 6 months, he's eliminating moonshot projects. He's saying quick wins, do something simple. I want you to start doing things with machine learning. The Gmail team initially just did some simple spam detection and things like that with AI and ML. But over time, they're doing very interesting things like the smart replies we all use with Gmail. It came out of this kind of an initiative. Similarly, Google Photos started to do better tagging of these photos using machine learning. So you can just type in, natural language words, and the system can pull up the images that are relevant. And Google made many acquisitions, DeepMind, Google Brain, and so on are initiatives they launched in order to create centers of excellence within the organization that can be used by other divisions to roll out AI projects. Even a division like their data center, which doesn't have a natural role for machine learning, was told you have to roll out machine learning in some way. They started by building a system that could predict energy usage within the data center. As you might know, HVAC, or that is heating, ventilation, and air conditioning costs, are a big part of the cost of running a data center. They initially just rolled out a system that could predict what the energy utilization would be like. And over time, over many years, it became a system that did automatic turning on and off of air conditioning within the data center. And this smart cooling actually reduced their energy use and energy cost by 40%. The third piece in here is reskilling the organization and investing in AI talent. And so that, first of all, is about retraining your employees. Google did this program where they kind of, first of all, rolled out courses within the organization. All the engineers were told, do you want to be a machine learning ninja? Here's a course you can take on campus, online, and here are the credits to do that. In addition to that, all the engineers were told you can spend 6 months outside of your product team and sit with a centralized machine learning team and work on projects there. It's a 6-month semi-sabbatical where you're working on things related to your product, but you spend it with the ML team. And after 6 months, you go back to your core product team. And many engineers got retrained in machine learning through this program. And after that, they went back to their product teams. And all of a sudden, now you have machine learning knowledge, which was centralized initially, being completely distributed, where every product team has machine learning capable staff, whether it's product managers or engineers within that. And it's not just about reskilling, it's also about hiring external experts. And so for Google, that meant, again, acquisition of things like DeepMind to bring in some of that expertise from outside. So there's a combination of reskilling and hiring that's happening. And what's extremely important is it's not just about investing in talent that can produce AI, meaning engineers and product managers. It's about investing in people who will consume AI. And so that's managers. It's about making sure that people who have no business creating a machine learning system, nonetheless, are reskilled so that they know how to work with machine learning systems and know when to use the predictions and suggestions from an AI system, when to question it, what are the right kinds of questions to ask, and so on. Now, at Wharton, we recognize this is going to be a really important need for organizations, which is why we set up the AI for Business initiative. And not only that, we are actually rolling out courses, not just for our students, but outside as well. So as an example, we have rolled out an AI for Business online course, which is on Wharton Online, which is meant for managers and not necessarily for data scientists. And so it's for managers to reskill themselves. We're doing a 4-course sequence with Coursera, which will be launched by the end of the year, which is an even more extensive AI for Business course that will be available for non-data scientists, non-engineers. And outside of that, I'm working with our alumni affairs group to also offer, hopefully, something that'll be a free course for Wharton alumni who want to get trained in AI to have an online course for Wharton alumni later this year as well. So I think this is something that we are actually spending a lot of time on. Very quickly, and I want to just move on to Q&A, focus on the long term. As I mentioned, with general purpose technologies, there are bound to be short-term failures. Even if you look at the internet, there was the dot-com bust. If you look at cloud computing, early initiatives saw failure. So it's all about taking a 10, 15-year viewpoint as opposed to looking for a 1-year return. And so that's where you kind of mix the portfolio of projects for short-term and long-term. And lastly, I want to mention AI-specific risks. And the point about AI-specific risks is that things can go wrong. Like, for example, with Microsoft A, when they had success in China, the same system failed here in the US because these systems are based on data. And the system was designed to look at data on Twitter and constantly retraining itself. And Twitter is less regulated than some of the social media sites in China. And people were intentionally trying to trip Microsoft A by tweeting at it in offensive ways. And Microsoft A picked up how to communicate with others on Twitter based on those tweets and started becoming more and more offensive very rapidly on its own. There have been other examples, racist photo tagging software from Google, Microsoft resume screening AI tool that had a gender bias. So many such examples. And these can be big risks to organizations. There can be legal risks when you use AI to make important decisions like loan approvals, and there are biases in there. You could get sued with that. There are reputational risks. And there are also regulatory risks when you make important decisions based on AI. Facebook, for example, is undergoing this investigation and assessment from the Housing and Urban Development Group, or rather authority, and that's specifically about biases in the ads Facebook is showing to people. And there was a race bias in those ads is the allegation that's been made. And it's again based on automated determination of who sees which ads for housing loans or who sees which housing ads and so on. So the point here is there are risks. The solution is not to abandon AI, but it's really about how do we manage those risks. So it's about figuring out how do we assess AI before rollout, how do we rigorously audit and monitor AI. And in fact, this is a big theme of my book, and you can read more about it there. So there are a few other themes here, which I'll kind of skip. And if people have an interest in entrepreneurship and AI, I can get into what's happening with AI entrepreneurship and what are some of the challenges there. Suffice it to say, this is a big theme in venture capital today. Lots of investments going on in AI, especially here in the US and in China. And China in particular is making big leaps through both government sponsored and also private venture capital investments going on in AI. But we can get into these if there's interest in Q&A. Lastly, I just want to talk about societal implications. I've already talked about the fact that AI systems can fail as well. They can have biases. And there are two kinds of harms. There's harms of allocation, where some scarce resource is allocated within society based on an AI system. Like imagine a loan approval or who gets invited for a job interview. And if an AI system has biases, because there have been biases in human decision-making in the past, and the AI system is trained based on that historical data, it's going to learn those biases, and that can be a problem. And there are harms of representation, which is where the AI system misrepresents a group in a damaging way. So imagine, again, an AI system as a TSA screening device that's trying to pick people who look suspicious. And if it, again, has a bias based on race or other factors, then there's harms associated with that as well. And of course, the big elephant in the room is what might AI do to jobs and employment? And it's clear that, you know, in areas like, say, transportation with driving jobs, or with e-commerce with jobs in the warehouse, customer service, and so on, all of those are likely to be heavily impacted. Several research studies in the last few years do not yet show any large-scale impact of AI on jobs in aggregate. They show it with very specific and certain kinds of tasks, like I mentioned, but not at the aggregate level, at the economic level. But this is too soon. And the question is, in the long term, with automation, how do you reskill people, and how do you figure out ways to protect people when there's rampant automation going on? So that's pretty much what I wanted to say. And I think my main point is, yes, there's a lot of hype around AI, but going beyond the hype, I think we have to recognize that AI is starting to show signs of being a general purpose technology, which means it will have an impact at the organizational level. You should think about, what does this mean for your organization? It will impact at the macro level. It will impact how do you want regulators to react? What do you expect from your elected representatives in terms of how they're thinking about AI? What is the strategy at a national level for AI? It also means there's going to be a lot of innovation here. And so from an investment and entrepreneurial standpoint, the opportunities are somewhat limitless as well.